Hello all, welcome back to the part D of the lecture 11. Or I'm going to do a small demo on time complexity of R and of the code that we wrote last video. So this is if you are from computer science or engineering background, and if you have taken a course on algorithms, then you understand this issue of time complexity, that if you write a code, how much time it takes to complete the code. That's the typical time complexity. And if you see, I want to show you a demo here. So you see, if you have this is the negative log likelihood function that I wrote, and here I wrote a for loop to compute the log likelihood value. Now what happens is, when in my previous video you have heard that I am saying that if you write for loop in R, then it might be not efficient way to write it. Instead we should write it in a vector form. What happens is, R is a high level language and its compiler is in C, and the compiler creates the machine language. So the whole thing gets computed in C language. But as a result, what happens if you're running, so it is, R is often called, both R in Python are often called interpretable language. Means if you write a for loop, every time the loop is running, it is going back to C, doing the computation, coming back. So that is where the for loop is. Now if you say run, let me copy this function, and I will show you this could be actually a painful, it could slow your computation to good extent. Let me write a v2 version, and v2 version will be, instead of, so basically what I want is, instead of ll0 I will just say replicate na comma n1 is the, and then ll equals to y times log p plus 1 minus y times log 1 minus p, and I don't need this piece of line, and then I need to do ll equal to just sum ll. That is, if I write this, if I just replace that two line with for loop with this this is called vectorization of code. Okay, so you avoid the, so I'm just doing vector operation here. So if I do this, then it's supposed to work much better, it's supposed to do quick job. So now I have the negative log likelihood is the way I wrote the function previously, and negative log like dot v2 is the next one which I vectorized. So what I'm going to do, or let me just run this code, both of them, and this is what I'm getting from the older version. Now first, it's supposed to give me the exact same value for my newer version also, the v2 dot v2 as well, right? You see here I called the older version, which gave me 485.203, and this is my newer version, which is also give me the exact same value. So it returns the exact same value, but how much time it takes? Let me just do that. Start sys dot time and sys dot time minus start, Okay, START. All right. So if I run the older version, so it is taking 0.00203, and similarly if I write this one, oopsie, sorry about that, START. So this is the one I'm going to do, and then yeah, so if I run this, so let me just run it once more. So the first one all right, let me see how much time it's taking. So this is the old one and this is the new one. So this is the old one divided by new one. So it looks like the new one is slightly faster. So what I will do, and same way what we can do is we can do the optimization will do. So let me just do the optimization with the old version and the new version. So an optimization will have to do some additional computation. So if I just run this with, so it takes about 0.08 second with the older version, and if I just run the same thing with the newer version, it takes little faster. It is little faster now, clearly 0.067. So about, so you know, this divided by this one is 1.26, almost 25% faster. So 25% faster is, this means if in this way you can make your code efficient. Now you can tell me that, okay sir, why, if whether one code is doing it 0.08 second or 0.06 second, do I really care in this case? So yes, if your data is small, probably you don't care that much, but as a developer you always aspire for writing code for very big data. You want to handle very big data, very big models, right? Now imagine you have such a big data that your one code, you have written two code, one code or two programmer has written two code, one programmer's code take 8.5 seconds, another programmer's code take 6.7 seconds. Which code, or 8.5 minutes and 8.5 hours. This could be like 8.5 hours and this could be 6.7 hours. Naturally, the same code, the same code will run on very big large data also, like millions of data points. Here you have only 1,000 data points, actually 700 data points on which you are trying to train this model. So but if you have millions of data points, it might take 8.5 hours or 6.7 hours. Now if you are running it on the cloud, that means, and cloud services typically charge you by minutes, sometimes even by seconds. So you are reducing your model training cost by almost 25%. If you use this code, the older code, it will cost you $125, and if you use the efficient code, it will cost you $100. So that means you are saving $25 in training very big large data on cloud. And there is another aspect to it, is that means your algorithm has less carbon footprint, because these cloud machines takes a lot of electricity, and those electricity are typically has at least in country like India uses a lot of fossil fuel. So that means effectively efficient code means less carbon footprint. So you better write your code which runs faster and gives you code as accurate as possible. So this time complexity, unfortunately, our statistics students don't get to read much, but it is extremely important to study algorithms and time complexity, space complexity, all these things. So yep, so this was a small video. I thought I should show you guys that it is extremely important to write an efficient code. Everyone should watch this video, and everyone should understand these concepts of time complexity. Thank you very much. See you in the next video.